how do you put in a certain a requirement to count a certain number of pullback bars, on renko bars, for renko bars here, right? So for example, if you want to ignore all the 1 bar pullbacks, but you want to see pullbacks for 2 bars or more. So if there's a pullback of 2 bars or more, maybe 2 or 3 or 4 bars or more, how do you kind of create that filter that eliminates 1 bar pullback, signals when there's only a 1 bar pullback, but you still want to keep the signals when there's at least a 2 bar pullback, or maybe 3 or 4 bar pullback. So that'll be the first question for today. Ready to go. Let's see here. So I'm just going to start working on the logic tab here. I'm going to hit the new button, and that's going to create a new logic board for me to work in here. And let's see, let's give this a name here. There. All right. So we're going to create a couple of pieces of logic here, so that we can require a certain number of pullback bars. Let's see. So as this screenshot shows, we're looking for basically a signal, after a pullback here. Let's see. So first thing, we kind of need to build the base signal here first, and I'm sure that screenshot probably came from a previous workshop where someone had asked, how do we build a signal after a pullback in a renko? So I'm going to kind of go through this fairly quickly here to build the base signal before we can start working on the logic that counts the number of pullback bars. So let's see here. I need an inflection solver first to get started. Right, because basically this signal, since we're working with renko bars, what we're looking at is price reversals, right? Whenever the bar reverses, which is what an inflection is. So an inflection on a chart is just a reversal in direction, right? Reversing up, reversing down. So let's get this inflection solver to look at price reversals, right? So there we go. A bunch of signals there, and all right. So that's just identifying whenever price. That's just identifying the reversal bar so far. So that gives us kind of the base. That gives us the base signal to work with here, right? So, and what we want to do is we want to eliminate that base signal there, and we want to eliminate that one as well, since that only has a 1 bar pullback. Let's see. All right. So essentially, to do this, we need to use the bar direction solver here. Yeah. So this is the key piece here, is the bar direction solver. So the default settings for the bar direction is it's only looking at the current bar, or 1 bar at a time, right? So simply put, we can see, it's just going to tell us the bar direction. Now, if we want, if we change the number of bars, so if I set this to 2, so now it's going to tell us when we have 2 bars in the same direction, right? So we can see here, when there's 1 bar in an up direction, there's no output. But as soon as we get to 2 bars in an up direction, we start getting an output, right? So we can see that basically all the reversal bars don't have a signal because it's the first bar in that direction, right? And so, so this is how we can identify when we get a 2 bar pullback. So we can see this 1 bar pullback, right? There's no short signal here because we only got 1 bar, 1 down bar. But over here, since we have multiple down bars, we're getting a signal from this solver here. So we need to do one more thing here, which is, we want to try to generate, a signal when the trend reverses again, but we're getting a short output, but ultimately we're looking for a long signal here, right? So again, if we go back to the screenshot, right, we're looking for a long signal after a 2 bar pullback or 2 down bars, right? So after 2 down bars, we're looking for a long signal. So we need to take these. Oops, let's see here. I'm trying to grab an arrow. We're trying to take these. We need to take this short signal and reverse it to a long signal here. So let's go to our function nodes, and we're going to use a long-short modifier to do this. So if I plug that in, right, the default mode for the long-short modifier is swap. So there we go. So now we can see these down bars are now giving us a long output, which can then be used to generate ultimately the long signal here when the trend reverses, right, when we get the reversal up bar. So all right, and I'm gonna rename this to tell me what it's doing. So it's simply just swapping or reversing the signals there. So all right, so essentially, this is kind of this simple version of it. So we can take our signals. So there we go. There's all of our signals. And now we can take this bar direction kind of filter in a way, plug that in there. And we need to do one more thing here. So if you notice, no signals. Well, and that is because, right, if we look at our bar direction filter, well, there's no output on the signal bar, right? There's no output there. So once the bars stop going down, once we stop having down bars, the signal ends. So we need to take these outputs and push them forward onto the next bar. Push them forward onto the reversal bar. And to do that, we can use the look back. That's one of the functions that the look back node can do. And there we go. So if I plug that in, and now let's take a look at the look back here. All right. So now, if we look at the outputs, right? Let's zoom in again here. So our second down bar doesn't have the signal, but if we take a look, now our up bar, right, so the signals that were coming from these down bars have been pushed forward 1 bar, and now we have a long signal on the reversal up bar, right? And that was due to the look back. And more specifically, that's what this displacement function does in NinjaTrader. So this displacement function is what does this. So that's what we're using the displacement. So if I set the displacement to 0, then we can see everything kind of goes back to normal, right? Down bars. So let's put that 1 back in there, and I also like to rename these look back nodes to displacement 1 or just dis1. And that lets me know what this function node is doing. It's just simply displacing, it's displacing the signals from these other nodes here. All right, so now let's put this back here. Let me shrink the chart up a little bit. There. Okay, so now let's connect our filter into the AND node. There we go. All right, and so now we have some filtered reversal signals here. So if you look, so this isn't, this doesn't look exactly like that image, but we're kind of missing a trend. So this is missing a trend filter, but the point, the question is specifically focused on how to eliminate these 1-bar pullbacks. And so if we look, there's no long signal, right? So the short signal is coming because we had multiple up bars, so if these up bars were the pullback, then that would be the short signal there. So again, this isn't this logic is just focusing on counting the number of bars in any particular direction there, right? So yeah, actually, I guess here, let me just so this looks nicer, let me just create a simple filter. Yeah, I'll just create a simple MACD filter here. So I'll just, so I'm going to use the threshold solver to see. I'm going to check to see if the MACD is above or below the 0 line. There. All right. So let's see here. So I need, let's plug the MACD in here. And let's see, make sure the MACD plot is selected. And I'm just going to use the default settings here because this is just going to be a very simple kind of trend filter. And then next, for when you're using the threshold solver, you do have to set the output. So there's no default outputs set for the threshold solver. So do remember to go in here and set some outputs, like so. All right. So there we go. There's kind of a simple MACD trend filter here. And so now, if I plug that in, there. Yeah, the MACD's, let's see. Yeah, the MACD kind of eliminated a bunch of these reversal signals here. But anyways, the point still is that we got rid of these 1-bar pullbacks, and now we can see signals when there's a multiple bar pullback here. Right. Yeah, so again, we got rid of this 1-bar pullback signal there. Now, let's take this a little step further so that this becomes a more useful educational video. So what if we want to, let's say we want to eliminate pullbacks when there's too many bars. Let's say we want to limit the pullbacks to 2, let's say that from 2 to, I don't know, 4 bars, maybe. Let's see what we have to work with here. That's a 2-bar, 3-bar pullback. Let's see. Yeah, we have a multi-bar pullback. So let's just limit the number of pullback bars to 4. So again, let me mark a couple of these. So we're going to get rid of this signal here because it had we only want to limit the pullback bars to 4. Right, so we'll get rid of that signal. Let's see. We'll get rid of this signal. That's a 2-bar pullback, so we'll keep that one. That's a 3-bar pullback, so that one we'll keep. That one we'll keep. Let's see, 1, 2, 3, 4, 5, 6, 7. So we'll get rid of this one. Too many pullback bars. Let's see, that's only got 3, so that one stays. There we go. So there's a 4-bar pullback. So we'll keep this one and eliminate that one there. All right, so how do we modify our logic for that? So let's see here. I'm going to finish labeling here. So this AND node here is an example of a 2 or more pullback bars. So I'll make another set of logic down here where we can say minimum of 2 and a maximum of 4 pullback bars. So let me start getting things set up down here. There's that. Let's see, it'd be a good idea. I should kind of rename this bar direction because it's set up to look for 2 bars, right? So I like to put a 2 bar in there. It tells me it's looking for a 2 bar direction. There. All right. So what I'm doing is I'm just kind of duplicating the logic here down below. So I'm just going to do this quickly. All right, so this is going to be a 2 bar to 4 bar pullback here. All right, so I'm going to need, basically now I'm going to need to detect when there's at least 4 bars, right? 4 bars in a row for this pullback. So I'm going to grab a new bar direction solver here. Let's put this down here, or over here. And let's see, let's name this. So this is going to be a 4 bar direction solver. And let's set the number of bars to 4. There. All right, so if we look at the chart, right, simply put, I'm sorry, I want to allow 4 bars, so actually I'm going to need to count. I need to detect when there's 5 bars, right? So 4 bars are our limit. So if we reach 5 bars, I need to know when we count 5 bars. There. Yeah, so looking at our triangle, right, we want to eliminate this down signal here. And so I can see the bar direction is basically telling me, oh, look, we counted 5 bars. So grab an arrow, right? So basically that's our 5th bar on this pullback, for this down signal that's going to happen here. So yeah, so this output here is what I'm going to use to know that, oh, we've had 5 bars during this run, right? Or during this pullback. So let me rename, put a 5 in there. So there we go, 5 bar direction. Now, to eliminate signals, what we need is to eliminate signals here. So let's kind of take a look at this, right? This 2 bar minimum filter here, right? So this logic here is basically, it's identifying a 2 bar minimum run, right? Actually, let's look at it this way, and that's the better way to look at it, right? So when there's a 1 bar, here we go. So when there's a 1 bar pullback, there's no signal, right? So the way you eliminate unwanted signals is you need to create an output that has no output, right? So this 0 output here, in combination with the AND node, is what gets rid of the 1 bar pullback signal. Right, so when we look at this, right, there's no short signal here because it's only a 1 bar, and the way that was accomplished was, well, we're looking for 2 bars, and so when there's only 1 bar, there's 0 output. So when I get this 5 bar count, I actually need to get rid of this output, this long output here. But I need an output when there are less, right? When there's 4 bars or less, I need an output here, but no output here. So I'm going to have to do some, basically I'm going to have to do some signal modifications here. So let's see. One of the things we can try is the invert. You know, we can see if the invert's going to work for us. And looking at this invert here, so here's our 5th bar. Remember, this is going to be a short signal here, right? We're trying to eliminate a short signal. But if I look at BloodHound's output, well, it has a short signal when we get to the 5th bars down here, right? And so we need to eliminate the short outputs here when we get right to the signal bar. We need to make sure that there's no short outputs so that there's no short signal, right? Remember, that's going to be, yeah, this is going to be a short signal here. So let's see here. So we need to get rid of the shorts. So let's use the long short modifier to do this. So I'm actually not getting rid of the shorts. I'm swapping, or I'm reversing the short outputs into long outputs, right? Or to look at this the other way, let's take a look at our bar direction solver again, right? So we notice that there's no long output here. So if I reverse this long output into short outputs, then I'll have no short output. And there we go. And that's what this long short modifier is doing for me. So there, it took the long outputs, reversed them into short outputs. So now I can see there's no short output here, which is exactly what I want, right? So when we get to that fifth pullback bar, I now have no output. And so this absence of an output, this 0 output, can be used to block the signal here on this reversal bar. So there. So let me rename this here. So again, this long short modifier, we're just using the swap mode. So, all right, so we have a combination of logic tweaking going on here. So this bar direction, we inverted the output, and then we're reversing the output to get what we want. So, and we need to do one more thing. So, right, this 0 output is on the up bars, but we need to push it forward onto the signal bar. So we need another look back node here, so we can displace that signal 1 bar forward onto the signal bar. So there, if we look now, so now there's no output here on the signal bar. All right, let's finish naming this again. Here. All right, so let's take a look at this AND node. There we go. All right, so there's one spot that we wanted to get rid of that output. So if we connect this filter in, this new filter into the AND node, and there we go. So we got rid of that signal now. And this signal we wanted to keep because it only had 4 bars prior to the signal, right? So let's scroll down the chart here. There we go. Got rid of that signal there because it had more than a 4 bar pullback. So again, if I disconnect this filter, there we go. So disconnecting that 4 bar maximum filter, the signal is back. Connect this signal back into the AND node, and now that signal's removed. And let's check these others. Yeah, here we go. So here's two long signals I think we wanted to remove. Let's disconnect again. Yeah, there we go. So 2 long signals that had too many, right, pullback bars. So if we connect our filter back again, there we go. Yeah, so this logic here is looking for a 4-bar maximum on the pullbacks. But in reality, we're counting the 5th bar. So we know that if we count 5 bars, which is what the solver is looking for, then we've exceeded our 4-bar maximum. So, all right, so that does it.